Good morning, students. Students, today we will discuss delay, sunset and early sunrise, twinkling of stars and apparent position of stars, and these all phenomena occur due to atmospheric refraction. So the topic is atmospheric refraction, delay, sunset and early sunrise and position of star. So today we will discuss first of all recapitulation, then we will discuss twinkling of stars. Next topic will be apparent position of star, then advanced sunrise and delay sunset. Then we will assess what we have studied today. Then we will summarize, and in last there will be homework for you. So today's topic comprises of three new terms: horizon, apparent position and vacuumed. First term is horizon. The line at which the earth's surface and the sky appears to meet is known as horizon, और इसे हिंदी में क्षितिज भी कहते हैं. Apparent position, position as seen by theoretical observer at the center of the moving earth. वो पोजीशन जो एक्चुअल नहीं है, but it seems to be there, it appears to be there. That position is known as apparent position. जैसे रेगिस्तान में एक बहुत ही गर्म दिन पे हमें मिराज का अनुभव होता है, हमें पानी नज़र आता है पर वो पानी वहाँ पर नहीं है. So that position of water you may say is apparent position. The third new term is vacuumed. Space devoid of matter. It means वो जगह जहाँ किसी प्रकार का कोई भी मैटर नहीं है is known as space. Now recapitulating, when light coming from star, it enters into the Earth's atmosphere, it undergoes refraction. And why it undergoes refraction? Due to varying optical densities of air at various altitudes. Formation of rainbow is due to dispersion of light, total internal reflection and refraction. These three phenomena take place when a rainbow is formed, and it is formed after rain when raindrops are suspended in the air. Example of atmospheric refraction: delay sunset, early sunrise, twinkling of stars, apparent position of star, etc. Now twinkling of stars. तारे क्यों टिमटिमाते हैं? कभी उनकी लाइट ज़्यादा तो कभी उनकी लाइट कम क्यों नज़र आती है? This effect is known as twinkling of stars. We all know that stars emit their own light. Due to this light, the star shines in night. When we look at a star in the sky in a clear night, we observe that the intensity of light coming from it changes continuously. At one moment, the star appears to be very bright, and the next moment it becomes very dim. And we say that star twinkles. The twinkling of a star is due to atmospheric refraction of star's light. As you can see in the figure, a light ray from a star is entering into the atmosphere and it undergoes refraction one after another before reaching the observer at the Earth's surface. When the light coming from a star enters the Earth's atmosphere, it undergoes refraction due to varying optical densities of air at various altitudes. The atmosphere is continuously changing, due to which the optical density of air at different levels in the atmosphere keeps on changing. The continuously changing atmosphere refracts the light from the star by different amounts from one moment to the next moment. When the atmosphere refracts more starlight towards us, the star appears to be bright, and when atmosphere refracts less starlight, then star appears to be dim. The starlight reaching our eyes increases and decreases continuously, and this is due to atmospheric refraction. Stars twinkle at night, but planets do not twinkle at night. Why is it so? Planets don't have their own light, but they reflect the light which fall on them. The stars appear very small to us because they are very far away from us. So, star can be considered to be a point source of light, a point object, a point source of light. The continuously changing atmosphere is able to cause variation in light coming from a point size object. It is due to refraction, because of which the star appears to twinkle. Whereas on the other hand, planets are bigger in size because they are nearer to the earth as compared to the star. So a planet can be considered to be a collection of very large number of point sources of light. The dimming effect produced by some of the point sources of light in one part of the planet is nullified by the brighter effect produced by some other point sources of light in the same planet on its other parts. Thus, the brightness of the planet always remains the same. Hence, it does not appear to twinkle. Same as in the case of sun, it is also a star, but it is nearer as compared to other stars. So, sun doesn't twinkle. The continuously changing atmosphere is unable to cause variation in the light coming from a big sized planet due to refraction, because of which the planet do not twinkle at all. Planets are considered as big sources of light. They are non-luminous objects, whereas stars are considered as point sources of light. So star twinkles and planet do not twinkles. Now, why stars appear higher than they actually are? It is also known as apparent position of star. Due to the atmospheric refraction, the stars seem to be higher in the sky than they actually are. As you can see in the figure, a star light ray is coming to an observer. After passing the atmosphere, it bends. Its path bends. Light from a star is refracted as it leaves the space and enters the Earth's atmosphere. Air higher up in the sky is rarer, but that the near the Earth's surface is denser. So as the light from the star comes down to the observer, the dense air bends the light more. Due to this refraction of star's light, the star appears to be at a higher position. Our nearest star, the sun, also seems to be higher than its actual position due to atmospheric refraction. Now coming to advanced sunrise and delay sunset. As you can see in the figure, the observer is at Earth, and this blue line represents horizon, and true position of the sun is below the horizon. But where is the apparent position? It is above the horizon. And why it is so? As you can say, from the true position, a light ray entering into the atmosphere bends and it reaches the observer. And the observer sees a apparent position of sun. Sometimes the refraction, or you may say bending of the light rays, tend to bring into view the object which are actually below the horizon, which we cannot see otherwise. Thus, we can see the sun about 2 minutes before the actual sunrise and 2 minutes after the actual sunset because of this atmospheric refraction, because of this bending of light due to different layers of atmosphere, different layers of air with different optical densities. Let us take the case of sunrise first. The actual sunrise takes place when the sun is just above the horizon. But due to refraction of sunlight caused by the atmosphere, we can see the rising sun about 2 minutes before it is actually above the horizon. When the sun is slightly below the horizon, as shown in figure, then the sun's light coming from less denser air to more denser air is refracted downwards. As it passes through atmosphere, it further bends and reaches the observer. Because of this atmospheric refraction, the sun appears to be raised above the horizon when actually it is slightly below the horizon. It is also due to atmospheric refraction that we can still see the sun for about 2 minutes even after the sun has set below the horizon. We can see the sun 2 minutes before the actual sunrise time and for 2 minutes after the actual sunset time. So, the time from sunrise to sunset is increased by about 4 minutes because of this atmospheric refraction. One more wonderful phenomena happens at sunrise and dawn. The sun appears flattened, you may say oval shaped, at sunrise and sunset. The apparent flattening of the sun's disk at sunrise and sunset is also due to this atmospheric refraction. Remember this point. So, let us consider some questions. First question is, stars seems higher than they actually are. Can you explain why? Yes, because of their apparent position and due to atmospheric refraction. And you have to lengthen the answer with respect to marks. Second question, name the phenomena due to which we get light from the sun even before the actual sunrise. And the phenomena is, yes, atmospheric refraction. Third question, explain why the sun is visible 2 minutes before the actual sunrise and 2 minutes even after the actual sunset. The next question, with the help of a label diagram, explain twinkling of stars. I hope you all can answer these questions. Let us wind up today's topic with summary. Due to atmospheric refraction, the stars seem to be higher in the sky than they actually are. It is known as apparent position. The continuously changing atmosphere refracts the light from the stars by different amounts from one moment to the next, and this is responsible for twinkling of stars. We can see the sun about 2 minutes before the actual sunrise and 2 minutes after the actual sunset because of atmospheric refraction, and it increases our day by 4 minutes. And here is homework for you. You have to solve Assignment number 37. Thank you and have a fruitful day.